Alrighty, so we are going to talk about the Michaelis-Menten equation. So we're going to go ahead and start all the way up here. This is the equation that we were given right here. And then we know that the initial rate of the reaction is V0 equals K2 and then ES. Okay, so the problem that we have is that we don't know what ES is because it forms during the reaction. But we can make kind of an assumption that it probably has a pretty low concentration and doesn't change because the rate of it is formed is equal to the rate of the breakdown. So we can kind of just assume that, if you will. So that leads us to this one right here. And then when we move down a little bit more, we also don't know what E is because it is the concentration of the free enzyme. So we know it's the concentration of the free enzyme, but we don't know the amount of that right there. But we do know that it is the sum of the free and the bound enzyme, and we know it's equal to the total concentration. So we know it's equal to the total of the concentration of the enzymes. So you've got E and ES equals E total. Then down in this equation right here, so right here, we now will substitute the total enzyme into the steady state equation. So that's that equation, and we're going to rearrange it because we want to solve for ES right here. So we've got our steady state equation up here, and we're just rearranging all of this to then get it to where we are solving for ES. So after we rearrange it, we are going to isolate it so that the rate constant, and then replace those constants with a new constant called the Michaelis constant. So that's actually Km. So we'll see that right down here. We're rearranging again and again. These are just two rearranging steps to where we can get that Km constant, which I said like earlier is that Michaelis constant, Km, right there. So that leads us down to V0. The reason why we have this is we're substituting the value of ES so that the rate is equal to the one up in equation 1. So we can kind of then bring it all the way back up. So we're kind of plugging it back into this one up here, down here. And then we have the maximum velocity, which is Vmax, and it's equal to the total enzyme concentration times the catalytic constant. And so we substitute Vmax into it, which is all the way down here at the very bottom. So it's a lot of steps. Mainly it's just rearranging everything to where we can get it to what we want to solve for, because like I said in the beginning, like we don't know the concentration of E or ES, but we do know that both of them combined equal the total enzyme, so we got to kind of do a little bit of assuming and stuff like that. This is a little bit more complex. I'm still grasping it myself, but hopefully this helps a little bit. Sorry, it was hard to write it all and get the recording to work. Let me see if I can get myself to show up here. Nope. I can't really tell. 1 minute. Looks like it. So you can, hopefully this helped a little bit, but overall, this is the main steps that it follows. And like I said earlier, it's just a lot of rearranging and getting it to what you want to solve for. So here's the equations that I hand wrote out for this. Sorry, it's really skinny and everything like that, but hopefully this helps, and yeah, thank you.